Hello, my name is Elijah Ramos, and today I will be going over math for 5th and 6th grades, ages 10 through 12. For 5th grade, I will be going over adding fractions, and for 6th grade, I will be going over factoring.
Alright, welcome back, kids. Today, we're going to be multiplying fractions. Alright, to multiply fractions is different than adding and subtracting fractions, because when we multiply fractions, we multiply straight across, so the denominators do not have to be equal to add or to multiply, like they do in adding and subtracting. So let's go over the first one. 6 over 8 times 3 over 12. So when we multiply straight across. So we multiply 6 times the 3 and 8 times the 12. So 6 times 3 is 18 over 8 times 12 is 96. And since these are both even numbers, we can reduce them to make the fraction smaller. So to reduce them, we need to find a common number that both of these can divide into. I'm thinking 2 might be small, 4, we can't use 4, so maybe 6. Let's try 6, because I know 6 can go into 18. So if we divided each side by 6, we would get 6 divided by 18 would give us 3, and 6 divided by 96 would give us 16. And since this cannot be reduced any further, that would be our answer, 3 over 16. For the next one, we have 1 over 2 times 4 over 5. So we do the same thing we did. We multiply 1 times 4 and 2 times 5. So 1 times 4 is 4, and 2 times 5 is 10. And since they're both even numbers again, we can reduce them. So if we divided each side by 2, it would give us 2 over 5, which cannot be reduced any further, so that would be our final answer. For the next one, we have 2 over 4 times 7 over 8. So let's set it up. We draw our arrows so we know what we're multiplying. So 2 times 7 is 14, and 4 times 8 is 32. And since they're both even numbers, again, we can divide them by 2. Two divided by 14 would give us 7. And 2 into 32 would give us 16. So that would be our final answer, 7 over 16. For the next one, we have 2 over 7 times 7 over 9. So let's set it up. We draw our arrow so we know what we're multiplying. Numerators and numerators, denominators and denominators. We have 2 times 7 is 14. And 7 times 9, which is 63. And since they're both divisible by one number, because they both have 7 in the numerator and 7 in the denominator, we can reduce them by 7. And 7 into 14 gives us 2. And 7 into 63 gives us 9. Oh, my bad. Right there. My mistake. 9. There we go. And that would be our final answer. For the next one, we have 4 over 10 times 1 over 6. So first, we need to draw our arrows so we know what we're multiplying with. So we have an arrow going from 4 to 1 and from 10 to 6. So 4 times 1 gives us 4 And 10 times 6 gives us 60. And since they're both even numbers, we can divide them. So if we divided them by 4, let's try 4, because there's a 4 in the numerator. 4 divided by 4 would give us 1, and 4 into 60 would give us 15. And that would be our final answer because 1 cannot be reduced any further. And for our last example today, we have 2 over 5 times 1 over 4. So first, we draw our arrow from the numerator to the numerator and the denominator to the denominator, and we multiply. 2 times 1 is 2, and 5 times 4 is 20. And since 2 and 20 are both even numbers, we can divide them both by 2, which would give us 2 into 2 would give us 1, and 2 into 20 would give us 10. And that would be our final answer. Now, I encourage you to do the rest of the problems on your own. There will be a picture provided at the end of this video showing the answers to see if you got them right or wrong. Thank you for watching. Bye. Welcome back, kids. Today we're going to be factoring numbers over all the way up to 500 to see and finding out if they are prime or not. So factoring numbers is the same as how we did it the last time. So if it's a prime number, it can only be multiplied by itself and 1, or 1 and itself. There we go. If it can be multiplied by more than 2 numbers, it is not prime. Or 2 or more numbers, I'm sorry, then it is prime. So for our first one, we have 162, and right off the bat we can tell that this number is not prime because it's an even number, and all even numbers are not prime other than 2, because they can be divided by at least 2. So if we took a 2 out of 162, we can take a 2 out since we know that it can be divided by 2, and that would give us 81. And if we can take 2 9s out of that, so we can put an X, and then we can put a 9 right there, and a 9 is just 3 times 3, and then 9, 3 times 3. So instead of writing 9, we can write 3 times 3 because we know that 3 times 3 equals 9, so we could write that since it would be, if we took 2 out of 162, it would give us 81, and we know that 9 times 9 equals 81. And so since there's more than one multiple that we can multiply by, it is not a prime number, so we would write no. For the second one, we have 247, and right off the bat we won't be able to know if this is prime or not because it's not an even number. It says the 7 here is not even, and that's what we're looking for, the last number, to see if it's even or not. So we're gonna have to try and divide by multiple numbers to see. So we can try 247 divided by 3, 4, 5, 6, 7, 8, 9, 12, 13, and here we go. Our first one would be 13, and if we took 13 out, it would be, and since 13 is a prime number, we can't break it down any further, and if we divided 13 by 247, it would give us 19. And since there's at least two multiples, two numbers to multiply by, it would make this not a prime number, so we would write no. For the next one, we have 401. And just looking at it, it's not an even number, so we can't multiply it by, we can't divide it by anything like 2, 4, 6, or 8, since it's not an even number, because even numbers can only equal even numbers. An even number will never be odd. So we have to try something, an odd number. So we take 401, and then we can divide it by 3, no, 7, 9, 13, 17, 19, and I haven't found a number since for 401, so I would infer to say that 401 is indeed a prime number because it has no factors. Now, for 205, we can tell that this will not be a prime number because it has a 5. And we know that anything that ends in a 5 or a 0 can be divided by 5. So we take 205 and divide that by 5 to find its factor. So we put 5 here, times, and 5 into 205 would give us 41. And since 41 is a prime number, it cannot be reduced any further. So we would leave it like this, 5 times 41. And since there's at least 2 factors, this would make this not a prime number. So we would write no. Okay, for the next one we have 373. Right off the bat, we can tell that it's leaning more toward being a prime number since it doesn't have a 5, 0, or 2 here. So we can't divide it by 5, 10, or any even number. And since it's all odd numbers, this will make it a little harder to find a factor. So we take 373 and we divide it by 3, 7, 9, 11, 13, 17, and 19. And I have not found a factor that can go into 373, so that would make this a prime number. So we would write yes. And for our last example today, we have 194. And right off the bat, we can tell that this will not be a prime number because it has a 4 at the end, which makes it an even number. And we can factor it. So we can take out a 2, and we can write times. And 2 into 194 gives us 197. No, I'm sorry. I mean 97, not 197. And since 97 cannot be factored any further, we would leave it like that. And we would write no, since this number is not a prime number. Now, after this video is over, there will be the answers provided after this video. Thank you for watching. Have a nice day. Bye.
Thank you for watching this video once again, and don't forget to like and share this video with your family and friends, and to comment down below on what you'd like me to cover in future videos. And remember to wash your hands, stay inside, and if at all possible, if you have to go out, keep a distance of 6 feet away from others. Thank you guys. See you later.